Today we're going to look at number 7, okay? So let's go ahead and dive right in. So a ball of mass 4m is dropped from rest from a height of 10 meters above the ground as shown. It undergoes a perfectly elastic collision with the ground and rebounds. At the instant the ball rebounds, a small piece of clay of mass m is released from rest from the original height h. Directly above the ball, as shown on the right, the clay, which is ascending, eventually collides with the ball, which is ascending. Assume that G equals 10, air resistance is negligible, and the collision process takes negligible time. So, let's go ahead and look at A. Okay? So, determine the speed of the ball immediately after it hits the ground. So it said this is an elastic collision, which means when the ball hits the ground, that's an elastic collision, which means that we can use energy, right? And so we know energy is conserved, so a good way to do this would be just setting up a regular old energy type question. So just let me go ahead and write EI equals EF, showing that we're using conservation of energy. Then we just have PEG, right, at the very top is equal to KE at the very bottom, okay? And we know that the kinetic energy at the right before it hits the ground and right after it hits the ground will be the same amount of kinetic energy because we know that it is an elastic collision, okay? So I just have mgh equals 1/2 mv squared. M's cancel. I need to solve for v, so I just have 2gh root equals v. Okay, but we actually have numbers here. So we'll have the square root of 2 times 10, which is the number they tell us to use for g. You can see that there in the problem. Times the height, which is also 10, equals v. So that will just give us the square root of 200 equals v. Excuse me. So, oops. Let me go ahead and type that into my calculator. So I get v equals 14 meters per second. Okay, so that will be the velocity both right before it hits the ground and also right after it hits the ground. Okay. Now let's go ahead and look at B. So that shouldn't have been too bad. That's just an energy question, knowing what elastic is. But B will be a little bit trickier. So it says, determine the time after the piece of clay is released at which the collision occurs. So I have this clay here. I have my ball basically just on the ground. I know that the height is this 10. And I want to know when are they actually going to collide. Okay? And so with this, I kind of need to set up an equation for both of these. I'm only interested in the y direction, so I don't have to worry about any x stuff. So let's first set up an equation for the ball, okay? So we're going to make the ball blue. We're going to set up an equation for the ball, okay? And so we have delta y equals VIT plus 1/2 AT squared. Actually, let's go ahead and show why we're going to pick that formula, okay? So let's go ahead and define our variables. So I have for the ball, I know delta y, that is a question mark, right? That's what I'm ultimately trying to find. Where will it be at, right? I also don't know t, okay? And then, so t is something I'm also looking for as well, okay? And then I know a will equal -10, and then I know vi equals 14, okay? Meters per second. You'll notice this is an example where we need to make sure that we have this negative sign here because that negative for acceleration needs to be the opposite direction as the initial velocity. Okay. Now let's go ahead and look at what we have for our clay. Okay. So I have my clay. And so here I also don't know what delta y will equal. Okay. I also don't know what the t will be. But I do know a equals -10. And I know that my VI here is going to just be 0 because it's being dropped, right? Okay. It's released, the clay is released from rest, okay? So that is an important thing to remember, that the clay is actually released from rest. So the key part here is that I know that these two things will be equal. Okay? Well, actually, let me restate that. Normally, we use delta y's, right? And so that's kind of where we're saying. We usually use delta y to just because we're only worried about the change in position. But you'll notice that these two things will have two different changes in position because they'll meet somewhere here, right? So the ball may come up to that point, and the clay will come down. So they'll have different delta y's. So instead of setting it up with delta y, what I'm going to do is say my y initial is equal to, for the ball, well, this will be 0, right? And then my y final, that's what I'm really looking for, okay? And then the same thing for the clay, except for my y initial will be 10, and my y final is what I'm looking for, right? And so now we can kind of go back to our earlier thought process, which is that these y's, these final y positions will be the same for both, okay? So let's go ahead and write out an equation. So I have y equals yi, or yf equals yi. Remember, you can use, knots or I, those are interchangeable, plus vit plus 1/2 at squared, okay? And then over for the clay, I have yf equals, same formula, plus vit plus 1/2 at squared, okay? Anytime you're trying to find where two objects are going to be at the same place at the same time, I would probably suggest using this formula. It's kind of the formula that tells you where it's at, right, based on initial conditions. Okay, so let's go ahead and plug. Well, before I plug in, we know that this is equal to this. Okay, so I can actually set those two things as equal to each other. So I have yi equals v. Sorry, let me go ahead and erase that. So I have yi plus vit plus 1/2 at squared is equal to yi plus vit plus 1/2 at squared. Okay, now let's go ahead and what are we trying to solve for? We're trying to solve for the time, right? Determine the time, okay? So we need to find out that initial time. So let's go ahead and plug in numbers. So we know that the initial of the ball is 0 plus 14 times t plus, this is going to be -5 1/2 of 10 t squared equals, and then over here we're going to have 10. Now my vi here is 0, so that whole part just goes away, plus -5 t squared, okay? And what you'll actually notice here is that we have this on both sides. So when I add plus 5t squared, that will actually just go away, okay? And so I'm left with 14t equals 10, okay? And so I just do t equals 10 divided by 14, and so that will give me 0.71 seconds, okay? If you look at the answer key, it actually says meters per second, but the correct units should be just seconds, okay? So that goes ahead and gives me part B. So let's go ahead and look at part C, okay? It says, determine the height above the ground at which the collision takes place, okay? So I already know my time is this, so I just need to find the final position of either one of these, okay? Let's go ahead and find the final position of the green one, so the clay, okay? So I have yf equals yi plus vit plus 1/2 at squared, right? So yf is what I'm looking for. This initial position is 10. Remember, this is 0 because my initial velocity is 0 plus -5t squared, okay? So I have yf equals 10 plus -5.71 squared. So let's go ahead and calculate that. So 5 times 0.71 times 0.71 equals, so we have 10 minus 2.5205 equals yf. So the final position of both of them is just going to be 10 minus that number. So we get 7.4 7. Okay? And so that will be my final position. Okay? So let's go ahead and look at part D. Determine the speeds of the ball and the piece of clay immediately before the collision. Okay? So, oops. Let's go ahead and make that black. So let's look at part D. Okay? So we want to find the velocity of both. So to me, there are multiple ways. You could go back to kinematics. We know the time. But I think I would use energy for this. Okay? And so I would just do PE equals... Actually, I changed my mind. I think you can use energy. Obviously, you have PE plus KE. Now, if I'm using energy, the best way to do this is... Let's do this for the clay first, okay? So I'm going to do this for the clay first, and I'm going to set H equal to 0 where they end up. So I have PE equals just KE, right? And so I have mgh equals 1/2 mv squared, m's cancel, and so v equals 2gh root. And so that will just equal the root of 2 times 10 times my h is just going to be this number right here, okay? That 2.5205, because that's the amount I actually fall, okay? And so we can go ahead and multiply that out. Take the square root. And we get 7.1 meters per second, okay? And this is going to be down, so I need to put that negative sign here. So I'll say velocity of clay is equal to negative 7.1 meters per second, okay? Now let's go ahead and do the ball. So I'm going to do the same exact thing, except for this time, I'm going to... So let me pause for a second here and just think about this. So I can calculate this, but you don't actually need to. And the reason you don't need to is because you know that the ball was dropped from the top in the same exact spot as the clay. And so that means when they get to the same position, they will have the same velocity. And since the ball going up has, it doesn't change its velocity, right? The way up and the way down are the same, just in opposite directions as far as the velocity goes, right? So at that position, that's the speed it's going to have, okay? So the velocity of the ball is going to be exactly the same, except for it is going to be up. So it'll be 7.1 meters per second, okay? So you end up getting a very similar answer there. Now, if you want to calculate it, you can. You could actually use the exact same calculation as we did before, PE equals KE. Alternatively, you could also, so this would be the exact same, saying, okay, I'm starting from the top, I'm falling to here, and I know the speed on the way up is the same as the speed on the way down, just the number changes, right? Alternatively, you could do kinematics, or you could also set up something like a KE at the bottom is equal to KE plus PE. This would probably be the easiest way to justify it. So you just have 1/2 mv squared equals 1/2 mv squared plus mgh. So all the m's cancel. We know our initial velocity is what we solved for earlier, right? That's at 14. Okay. So I have 1/2 14 squared equals 1/2. This is what I'm trying to find, plus 10 times my h, which is 7.47, right? Because it's going up 7.47. And so this should actually give you the same answer, that 7.1 meters per second, okay? So multiple ways to be able to find that answer. So let's go ahead and look at E. It says, if the ball and the clay stick together on impact, what is the magnitude of the and direction of their velocity immediately after the collision? Okay, I'm going to take a pause and come back to E in a minute. Okay, so I'll see you in the next video. Thanks so much.